For numbers 5 through 8, I'm going to set each of these equal to x, because then we can convert it to an exponential and solve this exponential equation, specifically by turning each side into having a common base. So for number 5, if we have log base 2 of 1/2, I'm going to say that equals x, so we can rewrite it as 2 to the x equals 1/2. Then I want each side of the equation to be the same base. And 2 and 1/2 can be both written as base 2. So 2 just stays 2, but 1/2 is 2 to the negative 1. Now that they're both base 2, I can just set the exponents equal, and in this case, x would just be negative 1. So that overall means log base 2 of 1/2 is negative 1. So number 6, it would look like this. We can switch that into exponential form. 4 to the power of x equals radical 32. So 4 and 32, after thinking about it, you realize they can both be written as base 2. So 4 is 2 squared. Now, the radical I'm going to get rid of and put as an exponent, because our whole deal here works that we're going to set it works because we're going to set the exponents equal. And if we have a radical, that it's better to think of it as an exponent so we can work with it. So 32 is 2 to the 5th. Okay, and now we multiply exponents together. So it's 2 to the 2x equals 2 to the 5/2. And now we can set the exponents equal. So 2x equals 5/2. Then we can divide by 2 to get 5/4. So log base 4 of radical 32 is 5/4. All right, number 7. So I'm going to rewrite it as 16 to some power equals 1/4. 16 and 4 can both be written as base 4. That'd be 4 squared to the x and 4 to the negative 1. You get negative 1 because that would just flip it to 1/4. Okay, so now we have 2x here equals negative 1. So x would be negative 1/2. And then number 8, I'll put that on the side here in blue. So I'm going to rewrite this. 243 to the x equals 1. Here we can, I guess, we can technically get the same base, but it's better just to realize the exponent that will turn anything into 1 is 0. So log base 243 of 1 is just 0.